Now I want to propose you a few exercises. So exercise number 1 is to define a sum monoid, which is just a monoid of int, and you can guess what it does. It will sum the ints that you provide through the combine operation. But then I want a different instance of monoid for int, which I call the min monoid, and I want to combine elements via the min operation. So think about it. How would you do this? What is the empty element? Think of the properties that the empty element has to satisfy and provide an implementation. And finally, I want, and this is actually a def, a monoid for a list of any type A. How will you do this? Actually, let's add a fourth exercise. And tell me, what do you think is the most natural instance of monoid for string? Okay, so feel free to pause the video and try this. Okay, I hope you tried it. The sum monoid is very straightforward. I can use instance. The empty value is of course the 0, and the sum is just the sum. And Scala allows for this very short syntax, so the definition is very, very short. Min is a little bit more tricky. The combine operation is easy, it's just the min between the two elements. But what do we do with the empty element? So we have to think about the properties. Remember that the empty element should have no effect on the combine operation. So what element can we use that whenever we do a min between that element and some other element, we get the other element? And this is curiously the max value for int. So think about it. If you try to get the min between any number, let's say 3, and the max value of int, which must be something really, really big, you will of course get the 3. And you can do that with every single int, and it will be the same. Okay, and the combine operation is just min, which can also be written like this. Moving on to list monoid. Monoid instance. So what is the combine operation for lists? Well, the most natural operation that we can choose for list is the concatenation. So it's the plus plus operator. So that will be our combine operation. What can be the empty element? Well, if you're using the concatenation, the empty element, that is the list that will not affect the result when you are concatenating, is the empty list, so nil. And the concatenation is basically this. So there you go. We have a monoid for list. And finally, let's think, what's a monoid for string? Let's do monoid.instance. So again, this is similar to the list if you think of a string as a list of characters. So the most natural operation, if you ask me, is the concatenation of strings. And the value that will have no effect on concatenation of strings is the empty string. So this monoid will get defined by the empty string and the concatenation of strings. Okay, let's try this. Notice that I didn't include the implicit keyword because we are going to have some issues with the fact that we are importing every instance using these implicits. So we're going to have clashes, and the compiler is not going to resolve the instance correctly. So For the sake of this example, let's just use them explicitly. So the sum monoid, I will combine two ints, and of course I expect to get the sum of the ints. The min monoid, I will combine again two ints, so 6 and 2, let's say, and I expect to get the minimum, which is 2. If I were to combine this with the empty element of the monoid, as you can see, I get the 6. So it didn't affect the combine operation. It returns the first element. If I reverse these arguments, it will be the same. I get the 6. So we can confirm that this is actually the empty element for the min monoid. We can test some bigger value. And of course, we always get the value. Moving on, let's try the least monoid. Let's pick an A. For example, I don't know, Boolean. Now let's combine two lists of Boolean, like true, false, and false, true. Sorry, this is lowercase. There you go. And it's just plain old list concatenation. Okay. What about the string monoid? We combine two strings and we get the concatenation, just as we would expect. Something that I want to remark is that this operation is associative, but it doesn't have to be commutative. So notice that this is not the same as doing this. We will clearly get a different string as a result. So remember that monoids are just associative, and actually semigroups are associatives, but not commutative necessarily. Keep that in mind. Okay, so this is everything I wanted to show you about monoids, and I see you in the next video.